Nathan Rutman, and the original author was of the presentation is Ben Evans. So I already presented you.
Right. So this is actually the work of Ben Evans. I'm just here presenting it because he couldn't make it to LAD. All right. So this work was really about changing how the HSM system inside of Lustre actually works at a pretty fundamental level. So we're going to go through kind of how it works today. So the beginning is you issue an LFS HSM command, right? So that's the LFS HSM archive or restore. Those commands get sent to the MDS, where the coordinator stores them, sticks them in a list, and hands them out to copy tools. Copy tools have registered with the MDS, and the MDS hands out, I guess, a limit of 3 to various copy tools. Copy tools then report their status periodically back to the MDS. The MDS eventually notes that they're completed when the copy tools say so, and then marks the files as done. So what are the problems with that? It turns out there are actually lots of them. So the first is just even with issuing the command in the first place, LFS HSM archive. Well, there's no way to actually issue that command from, for example, Robinhood. Robinhood has to use the LFS command when really there should just be a programmatic interface to something that lets you say, you know, archive a file, restore a file, do other actions on a file. And really, why should that have to go necessarily through Lustre at all? So maybe, why doesn't the policy engine directly issue a command to something that is in charge of actually moving data? This isn't really necessarily a Lustre function at all. The second problem really is that the coordinator itself on the metadata server is a FIFO. And that means there's no ability to prioritize requests in any way. So you might have issued 1,000 LFS archive commands, and then someone tries to read a file that's already been archived, and tries to do restore. That restore is stacked up behind your 1,000 archive commands, and your application that's waiting for this file just has to wait till all those 1,000 files get archived first, and then you get to the restore. So that's kind of a disaster in a lot of ways. There's also no ability to just reorganize those files. If you decide to change your priorities at some point, there's no way to kind of modify that that ordering. So the third part is the copy tools themselves. They've registered with the metadata servers. And that's not just the metadata server, that's every metadata server that's running coordinator, which is all of them. So you have to have this kind of all-to-all, every copy tool has to register with every MDS in order to provide services, well, or you have separate sets of copy tools. Either way, there's no kind of a centralized service that is able to handle all of the requests, again, making for kind of more complicated ordering of the results. And then finally, kind of the fourth point on kind of the list of problems here is that we don't have a way to kind of coordinate when something starts. So why does an HSM archive command have to wait for something to happen elsewhere? It should just be an asynchronous command that you just issue, and something takes care of it, and that's the end of it. And so why do we need to kind of register these copy tools? Why can't we just start the data movement completely independently of anything that Lustre knows about it? That allows us to do whatever we want to do in parallel as often as we want, and we just tell Lustre at the end that we're done. Okay, so how do we do that? We move the coordinator out of Lustre. So this is work that we have actually finished There's LU tickets for it, LU 10986. We are probably still undergoing some reviews for this, so I'm not sure we've pushed the final patches up to the WAM Cloud website yet, but this is all going upstream. This is an optional change. As we all know, you're not ever allowed to take anything out of Lustre. You can only add things. So we are adding another option for coordinator. In this case, you can use your internal coordinator. It still works just fine. There's a new option when you're starting the coordinator, say use the external coordinator instead. So why? Mainly for the prioritization scheme. So it's a big deal, especially in large systems where you might be doing lots of data movement. Leachy is talking about tiering. We're moving lots of files. And we really need to be able to have a lot of files in queue and at the same time to be very responsive when someone asks for a restore. So this is the kind of the major reason we want to be able to take the coordinator out of Lustre, is to be able to provide a lot more rich detail in what we want to move when. We could try to do it all inside the kernel in the coordinator itself, but people want different policies there. They may want to, some people may want to prioritize archives or restores. It's fundamentally too complicated to put inside the kernel, given all the complication and kernel harassment of dealing with this kind of thing. So, so C is not the right language to write it in anyhow. Preemption, let's say something happens. We want to immediately archive or move a bunch of files, for example, from flash to disk tier because, well, maybe, sorry, let's genericize it, from Lustre to an archive because we're running out of space in our Lustre system. That means we really need to move, big files fast right now. So let's preempt whatever's going on right now and kind of swap that out. So again, it's a version of prioritization. And also, as I was saying before, we don't necessarily want this to be tied on an MDS by MDS basis. There's no point in having MDSs kind of all able to issue their own sets of requests to their own sets of copy tools. Let's make a global system that's able to have a kind of a more universal view of what's going on. All right, and then again, what else? So that's one thing we want to do. Another thing we want to do, work. Work comes from a number of sources. It's not just from Lustre users saying they want to LFS archive something. Maybe there's a job scheduler that wants to stage in some files that are in your archive. Why should that job scheduler have to issue an LFS HSM restore command in order to get that archive file back into Lustre? Why can't it just tell something, a copy tool directly maybe, to restore the file? Why does it have to go through Lustre? And so that's another goal of this work, is to be able to federate the ability to start jobs from anywhere, not just, or start data movement requests from anywhere, not just from within Lustre itself. So this is, again, kind of more, the point of this is to be able to use not just Lustre user actions, but policy kind of driven movements, job scheduler driven movements from, who knows, your web GUI. So the idea really is to kind of take most of the requirements for doing the HSM management and move them outside of Lustre and just minimize the interaction with Lustre itself and say, Lustre, I'm going to tell you when I'm starting a job, when I'm starting a data movement and ending a data movement, and I will tell you that it's done, and you just report that and keep track of that, and everyone will be happy. Okay, so what have we actually done? So for archive, the idea is that we want to be able, as I was kind of saying, we want the data movers themselves, the endpoint of the data movement, to be able to initiate and finish the data movement completely on their own. So start an archive from the copy tool, start copying it off to your archive. When you finish, you just tell Lustre that it's been archived, right? Why do we need anything else? We don't need anything else inside of Lustre. Tell Lustre that it's been archived at the end. Lustre, make sure, of course, that the data hasn't changed. But that can all be done with an ioctl at the end of the copy tool process itself, just like it's done today. So failovers, we don't really care because your job hasn't finished. Therefore, your process hasn't finished. Therefore, you've never issued the octal at the end saying you've finished, and so the Lustre doesn't care. So go copy all as much as you want. Only tell it when you're done. Follows all the whatever. You're a normal client. You're reading a Lustre file. You follow all the Lustre normal POSIX locking mechanisms that Lustre provides. You can copy this as many times as you want. Keep track of it in whatever systems you want to. It doesn't matter. All right. What else? Restore. Why not say the same thing about restore? We can restore everything unilaterally from the archive back to Lustre. So we say your job scheduler wants to move the file from your tape storage back into Lustre. It says go ahead. When it's done, we mark the file at the end with an ioctl saying your file is now restored. You move it into store it in a temporary file. You do the layout swap with that ioctl at the end, and it's done. So again, fine. There's a little bit of a complication with restore in that Lustre itself can also issue restore and block when you're actually trying to access the data and it's not there. So in that case, what the MDS does is it takes a layout lock in today's mechanism. So we still need that activity, right? So we still need the MDS to block so that users trying to access the data are blocked until the data has been restored. So in this case, the MDS still takes the layout lock and it just waits for whatever copy tool to say that, to issue that octal to say that it's done, and at that point the MDS lets go. It doesn't need the coordinator to do any of this. We did need to make a bit of a change here to reacquire the lock after a failover. It used to be that the coordinator queue inside of Lustre was the source of where you could get the information of what Lustre was working on, right? What files were being restored. So that was the source of also reacquiring the lock when you were trying to do a restore. So in this case, you don't have that ability to replay those coordinator queue because the coordinator queue isn't even stored on the MDS anymore. There is no coordinator queue on the MDS. So it's up to the client now who's waiting on the lock to reacquire the lock after the failover. So this is using the normal lock replay mechanism that Lustre already has for everything else that it does with lock. So it actually, in a sense, kind of simplifies what's going on there. It doesn't have a unique mechanism anymore. It uses the regular lock replay. So, okay, so what does this look like now, kind of in our new world? You can still issue your LFS HSM archive commands, which still go to the MDS, or you can issue similar commands from something else, a job script or policy engine. All of those are just work. They go into your external coordinator now. That means we need a new path a little bit here from the MDS to your external coordinator. So we've added a new bit of work here as well. So we have this vertical line here going from the MDS to coordinator is what the external coordinator is all about. So it uses a netlink socket from the MDS when you've set the coordinator to external. It uses netlink, it sends it up to a user space process. You can put whatever you want in that user space process. So in our case, what we're doing at Cray is we have a user space process that merely sends it on to our web API, our REST web API, sends the request on to that REST API just like everything else is sending requests to our REST API. that then goes to our external coordinator. Our external coordinator has all these abilities now to prioritize things, rearrange things, and sends work off itself to our own copy tools, right? The copy tools, as they're working on Lustre stuff, do their copying from wherever sources to whatever targets. If those targets happen to be in Lustre, then it issues those same ioctls that the copy tools do today. Those ioctls tell the MDS that we've actually started data movements or ended data movements. And that lets the MDS then update the HSM attributes so that we can know that the file's been restored from a Lustre point of view. So, migrate. Another issue with, well, this isn't really an issue with HSM, but it's related to the process of tiering. And so, kind of in our broader picture, HSM is related to tiering in general, right? So just like moving data from Lustre to an archive is a movement between tiers, you can also imagine that moving data between a flash pool and a disk pool is also a movement between tiers. Well, in Lustre, those are two different things. One is HSM migrate, one of them is HSM archive, the other is migrate between pools. And really though, what you want is to use a mechanism that is a highly parallelized, efficient way of doing data copies in both cases. So in one case, it's movement between Lustre and an archive, and in the other case, it's the movement between a pool and another pool in Lustre. But as long as your copy tool is capable of doing that, why should there be completely separate mechanisms for doing that? So, and this also goes to one of the points that Li Shi was making earlier in his presentation, which was that when data movements are expensive, and especially if you're using the current LFS migrate command, which is a single-threaded operation on the client that you're issuing that migrate from, right? So that's a really slow process, especially for very big files. So it would be really nice to use your fancy parallelized group of copy tools that are sitting off, in space over here, to be able to do migrates as well. So let's do it. Change migrate to use the exact same mechanisms that HSM is using, right? So LFS migrate -- HSM, new command that does migrate using the same HSM mechanisms. All it's doing is sending the same request. So instead of HSM archive, we now send LFS migrate HSM, send it to the MDS sends it out to the external world, the external coordinator takes care of it. And now we're no longer doing it on the client in a single-threaded process, slow. We can do our prioritization on those requests as well, just like we can prioritize archives, and kind of make a much more universal mechanism that does all of the data movement. It really doesn't, it's almost trivial. So instead of, we just add a new flavor of command, instead of HSM migrate, instead of HSM archive, we just say, there's archive, there's restore, there's HSM delete, HSM remove, I guess. Now there's HSM migrate. Easy enough. Again, the MDS isn't actually doing anything other than passing on this request to something else. Okay, so that's it. Simple. What else? Mirror sync, same issue. Mirror syncs are local, single-threaded operation on a client. You're reading a big file, you're writing it that same big file to a different layout from a single client. Hey, let's do it using parallelized, efficient copy tools that we can prioritize requests on. We make these asynchronous now, these operations, right? The mirror sync and the migrate are now asynchronous rather than waiting for them to complete. You're just sending the requests off. And again, you get to use all your fancy, fun external data movement facilities to do this. So this is actually LU 9855. again, in progress. This one isn't not quite there yet with this one's, but this is coming up next. That's it. That was a short one, huh? And I can't answer anything technical because Ben did all the work.
Do you have questions for Nathan?
Well, I have one.
Just send an email, like the LU number for the first item you listed. I think you inverted a couple of numbers.
Oh, all right. What is it? What's the actual one?
It's the correct one is 10968 as opposed to 10986.
Oh, sorry. Okay.
I went to 10986 to sort of follow along playing the at-home game and was like, huh? This doesn't, what?
6-8, sorry.
Yeah, no, it's all good. I'm in the program now, so thanks.
So yeah, so Olaf, I think hopefully this helps you with your problem of 3 requests per copy tool. You can send as many requests as you want through this thing. Again, it just sends them all out as many as you want. Doesn't track them or limit them in any way. You could also send things that are not file requests. You could send, for example, a request to do something on a directory, migrate a directory. It would be up to your coordinator then to expand that directory into a series of files, series of requests that you could send off to your individual copy tools or tar them up or whatever.
Maybe.
So, I'm not against taking out code from Lustre. I would say that we couldn't remove the functionality, right, completely. But I mean, if the external coordinator, was still part of Lustre, we could take out the kernel side code, but we couldn't say, oh, we're going to delete the coordinator and there's nothing else working.
Yeah, I guess that's possible. So, it would be easy enough to replace the current coordinator with a user space version of the FIFO coordinator that there is now, and then say that's the only option is the external coordinator, and you can plug in whatever you want there, and we come with the default. I guess that'd be a possibility as well. We were just fearful that people were gonna be upset that we've messed with their current
Their
program,
current partially functioning coordinator.
It's going to break the copy tools as well.
Yeah, well, and there's a little bit more setup as well, right? As opposed to just starting your MDS with mount -- Lustre or mount -T Lustre. Now you would have to start your copy tool process as well. So it'd be it would be a change from the way people currently have to set it up. So we were just a little fearful. So
you would deprecate it and then give people notice, one release notice.
My expectation, and maybe my hope, is that people will see, oh yes, this is much better, and Robinhood will kind of make their version of a coordinator, and DMF might as well, and people will stop using the internal one, at which point we can kind of get rid of it completely. But yeah, that's a good point. We could do it earlier, I suppose, if we put a kind of a stubby one.
I guess I'm just a little bit surprised by the second part of your presentation with LFS Migrate and LFS Mira. It seems like they are basically what we want to do with an external coordinator. They would be the basic copy tool, and then I don't get why you want those requests to go through the MDS. I mean, at this point, you've already got the perfect tool. You just need to signal it to start migrating, and then you can parallelize it, of course. But
so there's no reason you can also issue requests without using Lustre to do migrates as well. Absolutely. And again, kind of in this picture, it would work just fine.
Yeah,
it's
why go through the trouble of making it possible to send them through the MDS if right now this is not supported and we actually don't want to do it? We don't want to involve the MDS anymore.
Oh, just to keep the LFS functionality that there is today. So right now, today you can say LFS migrate. So we wanted to allow people to still do that.
But that works without involving the MDS right now. So.
You still need the MDS to handle the changes to the file name.
Yeah, but you will still need this later as well. This is the operation that swap layout is basically going to stay, but you don't have to tell the MDS, oh, like, I'd like you to schedule and migrate for me.
So you're right. We didn't need to do that. There's a fairly strong desire, though, not to have external. So if you're a Lustre user and you want to do a migrate, and you want to do an efficient migrate that's not locally on your node, you can either use this new kind of LFS migrate -HSM, or you could write some other tool and you can issue a command to some other tool. But then your clients all have to be able to talk to this other tool. And if you're talking about just normal Lustre clients, we didn't want to impose the requirement that they all have to be able to speak to some external thing now. Right? So you can still just act as a local Lustre user here and just be able to issue commands a little more efficiently. So
okay, thank you.
There's no reason you couldn't do it that way, I guess. But yeah, that's why we wanted. We didn't want to impose additional requirements on the clients.
Thank you.
I would also note, sorry. I would also note that you need at least part of the MDS support just to support recall on demand.
Is to what?
Recall on access of a file.
Recall
restore,
on
you access. Mean? Yeah, recall a file on access. That also means that it gets initiated by the MDS semi-spontaneously because...
That's right. Yeah, so in that case, when you're trying to read a file that's been released, the MDS just issues that release command directly, when you try to open it, right? So it just issues the restore command directly to the coordinator in this case.
And one advantage that I see of retaining at least the form of the LFS HSM commands is that there is a standardized interface that you could use in scripts, etc., and that might work across different HSM implementations. So certain kinds of standardized testing scripts could be devised that work against both DMF and Robinhood and other HSM style things.
Yeah, so we tried very hard to make the external coordinator actually pass through HSM Sanity as well. So all of those commands all of the tests in HSM Sanity should be working as well. They just use this external coordinator. So that's now an option with, it just checks whether you've set your coordinator as external or not. And so there's a little bit of a difference in behavior of the blocking behavior, right? So especially of the restore request. So so it does check, but they should all pass.
I have a question. What's the interface here between the coordinator and the copy tool? Is it implementation specific, or is it standardized? API?
So that's completely up to you. So the only requirement is that you issue the correct ioctls to say you're starting, or ending the movement request in the right way. So the layout swap, if you're doing kind of a restore. But all of that coordination in the dark blue is completely up to you. So there's no registration anymore of the copy tools to the MDS in any way. If you want to make your own registration with your own coordinator, you can, or how it's opening it up to your implementation.
This imposed to have a strong coupling between the coordinator and the copy tool. And to have
there's an expectation. There's an expectation that if you're the one that's deciding a priority of requests, that your hardware is doing the data movement itself, right? That you're running copy tools on special hardware, that you are kind of distributing those jobs amongst your available hardware, that your coordinator is now a little more aware of your capacity, how many you can move 1 million files at once or not. So the expectation is that this is much more kind of dependent now on your actual hardware kind of implementation, what you're actually doing.
Hi, a small question about consistency. If the coordinator goes down or is restarted, is it the responsibility of the MDS to maintain a transaction log, for example, in the change log, or is it the coordinator who's responsible to keeping track of requests?
Yeah, it's up to the coordinator. So as soon as it acknowledges the netlink message, as far as Lustre is concerned, it's done with it. So we're not making Lustre keep track of all of this stuff at all. For the restores, as I kind of mentioned before, there's a lock that the client will maintain, like as it's waiting for a file, and if you never restore the file, then the client continues to wait on that log. So it'll wait forever. So it's up to the coordinator to make sure that that the durability of that request is maintained by the coordinator.
So if you're using one coordinator and changing to another, it's your responsibility to convert any statefulness?
Well, so I wouldn't expect you to be changing coordinators kind of mid-life, like from.
Well,
upgrading. I mean, you can't really, because you'd have to start Lustre up with, the specification that you're using an external coordinator. So as it starts up, if you're changing coordinators, yeah, it's your responsibility, I guess, to make sure that it figures out, what old work was from the old coordinator and import it into the new coordinator. Yeah, it's not something that we've concerned ourselves with.
Thank you.
One more then. If a file is in progress of being archived and someone starts updating it, do you handle that?
Does someone, if someone starts updating it?
Yeah.
Yeah, so that's up to so just like it is today, it's up to your copy tool to kind of issue the final, the complete command, basically the ioctl at the end where you're saying you're done. And that done ioctl checks the version of the file. And if the version of the file has changed, then the ioctl gets rejected, basically, yeah.
Thank you, Nathan. Very interesting.